Hi, I want to start this video by telling you to take notes as we go along and just do the best you can. Remember, you could stop the video at any time, replay back any parts. The first thing I want to do before we do the second example that we would have done in class today is just talk about why we never accept the null. Let's just say our null was that something was an elephant, and our alternative was that it wasn't an elephant. Well, let's just say we were doing our test and our evidence was that it had 2 legs. You could very easily say the likelihood that it's an elephant, given that it has 2 legs, is really low. I'm going to reject the null and say it's not an elephant. But what happens if the evidence were instead it had 4 legs? Now, at this point, you don't have enough evidence to reject the null and say it's not an elephant. But because it has 4 legs, is it definitely an elephant? No. So you can't prove the null is true. You can only say that the alternative is not true. That's why we're very particular when we fail to reject a null to say, because my p-value is high, we say, I fail to reject the null. Not prove it, we just haven't rejected. And I don't have evidence that the alternative in context is true. So the wording is very particular here. Okay, now we're going to go to the class example. Okay, the people that make M&Ms claim that 20% are purple. Okay, that's the commonly held belief. You go and open a bag of 122 and only 21 are purple. Does this contradict the company's claim of 20%? Our null, which is what we're going to believe in the beginning of this test, is that they're telling the truth and that 20% are purple. Now, the alternative here is they say, does this contradict? When you contradict, you can be contradicting by being too high or too low. So this is going to lead us to what we call a two-tailed test, and we're going to put not equals in the middle. Now, what's the third thing I have to do to get full credit for the hypotheses? Right? We don't know what P is. P is the true proportion of purple M&Ms. You always have to define your parameter. And remember, our test is always believing that the null is true, so we're going to use that true parameter until we find out otherwise. Now, we opened up a bag and 21 out of 122 were purple. So I'm going over here and let's see what that equals. So let's just call it for our purpose 0.17. So that's our evidence for our trial. Now we are going to go to part 2. We're going to check conditions. So here goes. We're going to go Ritln, R-I-T, and L-N. Now, just for time on this video, I'm going to do the first 3 verbally. Now, it doesn't say anything about the bag being randomly chosen, so all we could say is we hope the sample is representative. The color of one M&M should be plausibly independent of another M&M. For the 10%, we definitely know that 122 is less than 10% of all M&Ms in the world. Thank God, or else we wouldn't be able to have our M&Ms in class. So the big one that we have to check is large enough. This one I'm going to do out with you. Remember, at home, you do all of them. Now, remember, we're assuming the null is true, so that's the value we're going to use when we check our conditions. So our N was 122 times 0.2, and our Q will be 122 times 0.8. And I'm pretty sure that those are bigger than 10, but let's just go over here. 122 times 0.2 is 24.4. So that's 24.4 is bigger than 10. And then on the other side, 122 times 0.8 is 97.6. Bigger than 10. So I smile right now. My conditions have been satisfied, and now I go to the mechanics. So here goes. We're going to name our test. It is a one proportion Z test. We're not estimating the real value. We claim we know the real value, or we've been told it and we think it's something else. So let's draw our picture now. The true value they claim is 0.20. We now know the standard deviation has to be PQ over N. Again, we're assuming the null is true, so we're using that value and not the p hat. That's pretty huge. And we got a p hat of 0.17. But here's the issue. We said contradict. We can contradict by being too low or too high. So we want to shade the other tail. Now, you don't have to put in a number on the other tail, but 17 is 3 less than 20, so the other tail would start at 0.20. Again, not necessary, but we're saying how likely is if the real value is 0.20, I get something at least as extreme as 17% in either direction. So now we are going to make our z-score. Z is equal to 0.17 minus 0.20 over our standard deviation. I'm telling you right now, you can get the z-score, you can do a normal CDF, and then you're going to have to multiply it by 2 because of the two tails are congruent. I prefer not to do that. I'm going to go into my calculator and let it do all of the work for me. I'm just checking it was 21 out of 122. So here goes. Menu, stats, test, one proportion Z. My null is they claim it's 20%. And hold on, I'm silly, but I already forgot from a second ago. It was 21 out of 122. So we're going to put in 21 out of 122. And you see the null says not equal. We're going to leave that. When we do this, it tells me the z-score is negative 0.77. Let's round it to that, which isn't a very unusual z-score. And then the p-value, it said was, let's go back here, 0.44. So it's absolutely not unusual to get a sample statistic at least as extreme as ours in either direction if the true proportion is 20%. So therefore we are going to fail to reject the null. So that's our last part. Remember, low reject the ho. Our p-value is very high. We're saying that getting a sample statistic that's similar to ours is probably just due to natural sampling variation and could very easily happen if the true proportion of purple was 20%. So our conclusion, because my p-value is high, I fail to reject the null. This isn't enough. Now you have to say a conclusion in context. And my conclusion in context will be, I do not have evidence that the proportion of purple M&Ms does not equal 0.20. So, to conclude, we're just going to go through this really quickly. This is a two-tailed test because I don't know a direction. It just said contradict. It didn't say in which direction. I assume the null was true, so that's what I used for the large enough condition, and that's what I used in the standard deviation. The difference of this test was contradict in either way. So it could be as low as 17% or lower, or as high as, this should be a 23% or higher. You do not have to plug in that number on the top. We get our z-score. Now, if you like, you can work this out and get that. And you could do the probability of z less than negative 0.77, and it'll be approximately 0.22 if you do normal CDF, but then you're going to have to take that answer and multiply it by 2 because you have two tails. I much prefer to do the one proportion z test on the calculator and let it multiply and do everything for you so you get your final answer with both tails. High p-value, we failed to reject the null. Doesn't mean we proved the null is true, we just didn't reject it. And we don't have evidence that the proportion's not equal to 20%. The last thing I want to say is that think about what the p-value is saying, really. It's saying the probability that we observed a sample proportion at least as extreme as 17% in either direction, so at least as extreme could be too high or too low, given the true proportion of purple is 20%, is about 44%. That's an awful lot. So we're not saying that it's unusual, and we're saying we don't have evidence to reject the null. Okay, folks, go for that homework, and I hope this helped.